Welcome to Statics.
Example: force and couple system simplification in 2 dimensions. In this example, we have a structure with 3 forces applied. All structure elements and forces are in the plane of the screen, so this is a 2-dimensional problem. We are given their magnitudes, directions, and locations on the structure. We will find the magnitude of the resultant force at point A, its direction, theta, and the resultant moment at point A. Let's begin with the magnitude of the resultant force. We will get it by summing forces in the x and y directions. Starting with the x or horizontal direction, we will use the standard convention of forces pointing to the right are positive. We have F2 acting to the left as negative 100, and the horizontal component of F3 also acting to the left as negative 400 cosine 40. Simplifying, we get negative 406.4 newtons. Now the y direction, with forces directed upwards as positive. We have F1 acting downward as negative 600, and the vertical component of F3 also acting downward as negative 400 sine 40. Simplifying, we get negative 857.1 newtons. We get the magnitude of the resultant using the Pythagorean theorem. We get 948.6 newtons. Next, we will get the direction of the resultant force using the tangent function. The tangent of theta is equal to the vertical force component divided by the horizontal component. We get 64.6 degrees. The direction can be visualized by drawing a force triangle, with the horizontal component and the vertical component both negative, and we can see the direction of the resultant is in the 3rd quadrant. Last, we will get the resultant moment at point A by summing the moments with respect to point A. That means that the moment arm dimensions will be found originating from point A. We will divide the forces into vertical and horizontal components. We will use the right-hand rule to determine direction. Let's start with F1. It is vertical and causing a clockwise or negative rotation about point A. So I write negative 600 times its horizontal offset from point A, 0.4 meters. The line of action of force F2 passes through point A, so its moment arm is 0 and it does not show up in our equation. We break F3 into components. First, the vertical component is 400 sine 40, causing negative rotation, and its moment arm is the horizontal distance from point A to the point it acts on the structure, 0.4 meters plus 0.4 meters, or 0.8 meters. Now the horizontal component, which is 400 cosine 40, also causing negative direction rotation. Since it is a horizontal force, its moment arm is in the vertical direction. The offset from point A is 0.3 meters. Just as a quick check, I consider units. I see that each term of my equation has one force term, newtons, and one dimension term, meters. And that is what I want. Simplifying, we get negative 537.6 newton meters, or 537.6 newton meters clockwise. Let's quickly review our results. Our original system is on the left, and our equivalent simplified system is on the right. We simplified the 3 forces acting at various locations and in various directions into a single force and a single moment acting at point A. We have both the magnitude and direction of the resultant force and moment.